Thank you for joining us. I don't think it's just the rain that brought you in under the tent. This is a hot topic. Before we start, I do just want to ask, how many of you were in the big data session this morning? So I want to, fewer than I thought, that's good. So this is not going to be a repeat, although there was a lot of discussion of artificial intelligence this morning, but I want to assure you we're going to go in a slightly different direction. What we're doing is called a deep dive. Only in Aspen is 80 minutes enough time to go deep, but it's more than the 50 that you get in the other sessions. And what that gives us is a little opportunity to go deeper. And for us, what that means is we're really going to talk about use cases. We're going to talk about applications, where we're going, what the opportunities are, not in some theoretical sense, and how much those opportunities are continuous or discontinuous with what we were doing before we had artificial intelligence. So we have a sense of grounding of how real this is, how it's being used. And we'll get into a variety of other issues as well. We're going to start with a bit of a primer because the terminology is complex and we want to make sure we're working from the same place. We'll then get into some use cases from our various panelists. At a little bit past the halfway mark, we're going to start talking about AI in low resource environments, which raises a different set of issues. And one of the great things about Aspen Ideas is that we bring on the health side, as we bring together domestic and global. We're going to do that in this session as well. Mike Nohaile is to my immediate left, the Senior Vice President of Strategy at Amgen. Lizzie Dorfman, Senior Technical Program Manager at Google AI. P. Anandan, the CEO of the Wadhwani Institute for Artificial Intelligence. And Catherine Mohr, President of the Intuitive Foundation. And more information on them is on the app, but enough to give you a sense of where we're starting. So who would you ask to give a primer on AI? Someone from Google. And indeed, I did a session with Lizzie last year, so I know she's up to the task. So Lizzie, if you could just kick us off, get us all grounded so that as we take this deep dive, we're starting from about the same spot.
So thank you. So I'm coming from Google, but I'm going to spend the next couple of minutes trying to spare you all from Googling words as we enter into this deep dive. If you were in this morning's big data session, there will be a little bit of overlap, but the terms that I'm going to be talking about, big data, artificial intelligence, machine learning, and deep learning, whether they're part of your daily lives and work or not, these are starting to become water cooler terms, and having everybody have some sense of what they do and what they don't mean, I think is quite beneficial. And I hope that you'll use this as you move forward in some of your discussions. So let's start with big data. This is probably the least specific of all of those terms, but generally speaking, this is referring to data sets that are so large, so complex, and so diverse that they've really forced us to rethink methods around how we collect them, how we store and transport them, and in particular, how we analyze them. Artificial intelligence refers to computers that are able to perform tasks that are typically understood to require human levels of cognition or intelligence. This is, applications of this would be things like understanding and using human speech. I'll give you some Google examples. Our Translate products, which allow you to do real-time translation from one language to the next, or real-time transcription. This is also the type of technology that's used to do things like suggesting the end of an email that you're writing. Another example would be the ability to understand and identify content within an image. The reason that you can pull out your phone and for Google image search, look up a word and instantly see all of the photos that have whatever you were searching for within them. This is based on AI. Another example would be motion planning for robots, which might be surgical in nature, might also be a vehicle. Obviously, Google has an organization called Waze that's focused on, well, Waze, yeah, Waymo. I'm mixed up. Waze is also Google, but that's traffic navigation. One of the important distinctions to be very aware of when it comes to AI is between artificial general intelligence and narrow AI. So artificial general intelligence would refer to a computer that could perform any possible human cognitive task. And at present, and for the extended and foreseeable future, this is the stuff of science fiction. We are not remotely close to achieving that level of AI. But what we do have is an increasing number of applications where computers are able to meet, or in some cases even exceed, human-level performance for very, very specific tasks. We have seen several public examples of this in the gaming space. Lots of news when you had a computer beat world champions at chess and at Go. We've also seen a number of examples of this in tasks related to image classification, including several medical imaging, and I'll be talking about several of those examples a bit later today. So the question that results is how machines become intelligence, and there's several approaches that they can take, one of which is a brute force method, sometimes known as good old-fashioned AI, where you have pre-programmed all possible scenarios and explicit rules for the computer to follow. A good example of this would be IBM's chess-playing computer Deep Blue. However, there are a set of methods known as machine learning methods that don't pre-program explicit rules, and instead they are showing the machinery specific training examples and allowing the computer to develop specific methods used to make classifications or predictions. Deep learning, which we're starting to hear used much more, is a specific type of machine learning that's exceptionally powerful when you're working with images. And the deep part of deep learning refers to the fact that there is a series of transformations that are happening to those images, where you go from pattern detection of very, very simple features, for example, an edge, to much more complex features that are frequently things we would consider human recognizable, like a face or some text. So to wrap all of these up together, deep learning is an increasingly common and very powerful type of machine learning. Machine learning is one of the ways that computers achieve intelligence or artificial intelligence. Big data is still a sort of a fairly vague and broad term, but really it's primarily focused around having to rethink the methods that we use to analyze increasingly large, diverse, and complex data sets.
Great. So with that terminology, of course, applications for AI abound. We're here at Ideas Health, and so even within the domain of health, the variety of applications is quite profound. And what I'm going to ask each of our panelists here to do is to just spend a couple of minutes describing a core application, maybe a little bit of a mapping onto the taxonomy you gave us, so that we have a sense of the incredible breadth of what is actually already occurring in the domain of artificial intelligence. Catherine, you want to kick us off?
Sure. So I think of the panelists up here represent procedural medicine, surgeries, biopsies, endoscopies, the sorts of active things that surgeons or practitioners do to their patients. And we're using AI and will be using AI in the future in a variety of different ways. But to give you a little bit of motivation around why we are focusing on the certain sorts of things that we are, I have a cheat sheet on some of the data that I wanted to give you, because it was apparent, especially from Peggy Clark's opening, that surgery is considered a little bit of a luxury, and a lot of the things that we've been talking about have been in the, sort of in the areas of what we would think of as more general medicine. But just a few numbers on surgery. So globally, there are a little over 300 million surgeries per year, but there are 5 billion people on the planet that lack any kind of access to basic surgery. And so what that means is that there are about 17 million potentially preventable deaths that could have been cured if there had been surgery available. To put that in perspective, about 10 million people a year die of cancer. So 17 million from preventable surgical access, if they'd had access to surgery, versus 10 million a year that die of cancer, versus 3 million a year for HIV, TB, malaria combined. So surgery and lack of access to surgery is a real public health issue. It's not a luxury. It's actually, lack of access is something that's killing more people yearly than things that we think of traditionally as public health. So, but surgery is not a panacea. We do 300 million surgeries a year globally, and 4 million people who received surgery die within 30 days of receiving that surgery. So it is not without risk, and that means that we need to be doing a lot better. So keep in mind that 3 million, HIV, malaria, and TB, 4 million are dying within 30 days of having surgery, which meant if we did it better, there's probably a lot of preventable deaths in that as well. If we were to expand the opportunity for surgery to the entire globe, we'd probably be looking at about 450 million surgeries being done a year, and that would mean 6 million people dying within 30 days of receiving their surgery. So this is why, just to give you that context, why I'm focusing on the somewhat peculiar areas that without that context, you might wonder, why are we looking at that? And so the areas that I'm looking at are clinical decision-making. How do we help surgeons make better clinical decisions during their operations? And then surgical training. If you want to train, you can build a hospital in a year. If you want to staff that hospital, it will take you 10 years to train the people to staff that hospital. If you're trying to meet the public health crisis of not having enough surgery, you're going to have to figure out how you train those people better and faster and how you build that kind of infrastructure. So what do we use AI and machine learning for currently in surgery? A lot of the image recognition, we're looking at CT scans, we're looking at preoperative images, we are figuring out where a tumor is. You can navigate, you can help the surgeon navigate to where that tumor is intraoperatively. There are new kinds of fluorescence imaging that we're putting on there that you can then do image analysis and you can help people. It's essentially, how do I give the patient that I'm working on a better surgery because I am able to get better information out of this data? Where we will go in the future is, as we're looking at video-based data, a lot of these procedures, if they're endoscopic or robotic or laparoscopic or your colonoscopy, there's a video component to the data. And you can do a lot of parsing of that into being able to recognize the different sections of that procedure. And as you start to look at, in the future, what kinds of outcomes came out of that, you can start recognizing correlations between actions that happened during surgery and better outcomes associated with that. From this, we start to be able to build AI coaches. Along with you, looking over your shoulder, helping you do a better surgery, but also being part of accelerating the learning curve on these millions of surgeons and millions of new nurses that we're going to need in this kind of procedural healthcare world. So I said I was going to focus on things that were very different from what everyone else was talking about, because in the world of procedural medicine, a lot of the things that we are thinking about is AI and machine learning in decision-making, in being able to avoid complications intraoperatively, and in the future, that's what we're doing now, in the future, being able to bring in these AI coaches.
Great, thank you. Anandan, your work, of course, goes beyond health, but if you could focus on some of the AI applications in health that you're working on.
Thanks, Alan. Yeah, I run Padmanabhan Institute for AI, AI for Social Good. It's a not-for-profit working in low-resource communities. Primarily, we are looking at health as one of the areas, say health for the global south. So roughly 3 billion people who don't have adequate medical care. There is not enough doctors, enough nurses. Ratios are of the order of 30,000 patients to a doctor and such. So clearly there are a number of places where we want to augment the capacity of frontline health workers and others using AI type of technology, and that's the opportunity. We've been around for 1 year. One of the things we learned is in choosing use cases is that you have to talk to 3 different parties. The governments who ultimately own the caregiving to these large populations. For example, India, where we are based, we're talking about 800 million people who are part of the public healthcare system. NGOs that are field NGOs who know how to provide care, deliver solutions, execute whatever technology you develop who know where to go and deliver the solutions. You have to talk to them. And third, sometimes there are tech apps that are part of the system, and the makers of those apps, you have to talk to them. And whatever you build needs to be in consistency with these organizations, because they're the ones who can enable getting the solution. So we, in our first year's journey, came up with a couple of areas where we want to focus. There are many, but just to pick the two: maternal and child health, maternal and neonatal child health, and TB. So I'll talk a little bit about use cases on each of them. In MNCH, for example, one problem we zoned in on, again, conversations with all the partners, is low baby birth weight detection. It turns out there are something like 20 million low birth weight babies born. In India, the number is of the order of 4 to 5 million. But 30% of those babies, say for example in countries like India, are not weighed at birth. There is an existing protocol to do so, using frontline health workers carrying spring balances and weighing at clinics or at home. But often there are supply chain problems, the balances don't work, or the cumbersome process of doing it, or even, in fact, you cannot touch the baby because of taboos and such. So we realized that it may be possible to do that by simply taking a cell phone video or a few images and using computer vision techniques, namely AI, to create a three-dimensional virtual shape of the baby. And from that shape, take a lot of body measurements, and we know that the volume of the baby and the weight are closely related. Density is almost constant, so we could get the weight. And this is something, as we start doing, we realize, of course, there's a whole data collection problem, which I can talk about later, but seems like an exciting opportunity. The second one, as I mentioned, TB, the entire cascade of TB, from finding the cases to diagnosis and screening and treatment adherence, all faced with challenges. Numbers are of the order of, say in India, for example, that it's believed to be about 4 million annual new TB cases, but only 1.5 million known cases, those who go to public doctors and then are notified. Can we use that information and correlate with other demographic data or population data or even personal data to triangulate and see where there might be more cases in small regions, wards and blocks and such, so we can focus the caseworkers' effort on finding new cases. Again, there are other aspects of this as well where AI is amenable. But in all of these, one thing that you learn is that you have to work with the partners that I mentioned earlier, and they have to be co-creators, and they have to be willing to implement, and the governments have to be willing to scale. So.
Great. Mike, I'm gonna jump over Lizzie because she kicked us off, and then we'll give her a shot too. But Mike, why don't you give us?
So I think the fundamental challenge we face as a biotech company is that even if you advance really impressive innovation that can make a difference in a terrible disease, it's not always used properly. All the patients aren't found. If the patients are identified, they're not always put on the therapy that's optimal for them. If they're put on the therapy that's optimal for them, they're not always able to stick with it or take it and derive the benefit. So I'm going to focus on one area, osteoporosis, that we work in, and it's a fundamental issue at the beginning of that funnel. Only about 1 in 4 women who have osteoporosis are being adequately treated, and many of them don't even know they have the disease. So I'm going to give 2 use cases. One that is directly based on the techniques that you spoke of, which is an image technique, and then one that's based on something else that I'm excited about, but I would still call artificial intelligence. So the first one, the image one, the challenge is that many women start to get what are called compression fractures in their spine. So they have these small fractures in their spine. Sometimes they can be quite painful, but sometimes they're painless. And so they don't know. But if you have a compression fracture, you're heading for a hip fracture. And of course, you get a hip fracture, you may never get up again. In fact, you're likely to never get up again if you're old enough. So what we've done, in this case working with an outside company, is develop an imaging technique along the lines that was discussed. And what it does is it crawls through EMRs in a hospital, and it just looks at all the incidental images. Maybe you came in and they looked at your lungs, pneumonia suspicion, and they just wanted to check or whatever. But in the background is your spine. And so the radiologist doesn't look because they're human and they're busy and they have many, many other things to do. However, the machine doesn't get tired, so it just continues to crawl through and look at all those images. And then all it does is flag the doctor if it finds a potential compression fracture and say, hey, you should take a look here. Maybe this is somebody that should be worked up for potential osteoporosis. And we actually have that working. It's actually in a hospital system now in the middle of a test and looks pretty good. It looks like it pulls out a significant number of people in that situation. And again, it's not making the final decision, but it's highlighting people for the doctor to look at. And I think that's going to be an important way in the future to think about identifying patients. Along the same line, even earlier, or even with less information, the second technique I'm excited about are predictive analytic techniques, where you take streams of data and you predict how that would go into the future. It's not an image technique, but in this case, what we're able to do is use a set of techniques that are actually related to what we use in natural language processing to predict the next word in a sentence, and take an EMR record and predict what the next word of that sentence was. And sometimes the next word is bone break. Right? So then you can create a predictive score. So the standard today is something called FRAX, which creates a predictive score that says in the next 10 years, this woman is likely to fracture to a certain level. Well, that's great, but 10 years doesn't really motivate people. 10 years doesn't motivate insurers. 10 years doesn't motivate people. So using these techniques, we were able to get a version that we think might be able to give you a 2-year score. Right? And 2 years much more motivated, even to insurers who can see the payoff for preventing that fracture in 2 years. So that's still more in validation. The first data set looks good, but always what you have to do is when you do it, then you have to put it on naive data sets that have never seen it to make sure you haven't fooled yourself, and it's possible we have. But again, I think that's the kind of technology that hopefully will allow doctors and other caregivers to be armed with much better information and to focus their attention on the right patients, because if they have to spend all their time just finding those right patients, that's diluting the precious time and skill that they have.
And Lizzie.
So I'm going to give 2 examples. My background and training is in genetics and public health, and the examples I'm going to give relate to neither of those fields. But I have had some involvement in one of the projects, and I would like to sort of plant in all of your minds a sense of the breadth of applications to health and healthcare. So the first example is in radiology, focused on lung cancer. Catherine, you mentioned 10 million cancer deaths per year. About 1.8 million of those cancer deaths are from lung cancer. In the US, it's about 180,000 deaths last year. It's the top cancer-related cause of death for men and for women. If you screen people using low-dose CT, you can lower the cancer death rate for lung cancer by about 20 to 35%. And the US Preventative Services Task Force recommends that you screen high-risk individuals, mostly smokers. The challenge is that we have serious shortages of radiologists in many places. In the US, the ratio of radiologists to population is about 1 to 10,000. In some parts of India, this looks closer to 1 to 100,000. I was reading an article last week. Nigeria has 190 million people and fewer than 60 radiologists. That puts the ratio at over 2.5 million to 1. Clearly cannot scale to be able to handle that we don't have the amount of expertise that would be necessary. So some recent work published just in the last couple of weeks by the radiology team within Google AI and Google Health in Nature Medicine showed that we have been able to train a deep learning model. This is, again, the image classification method that we've been talking about, that actually is able to meet and in some cases exceed radiologist level accuracy for identifying potentially cancerous nodules in low-dose CT. If it sees one low-dose CT, doesn't have any historical data, it actually was better than radiologists. It had 11% fewer false positives and 5% fewer false negatives. And if it did have longitudinal data, then its accuracy was on par with radiologists. So this was just published. This has not yet been turned into a commercial product or available algorithm, but I think that's showing us how we can map these capabilities to areas of tremendous need. I will very briefly talk about a second and completely different project, which is not at all about clinical decision support or decision making. It's about helping make doctors' lives easier by trying to not require them to spend as much time sitting in front of computers and typing in information. So this work is focused around, we call it scribing, or this is known as scribing, but is it possible to capture audio data of what's being communicated between a doctor and a patient in a medical exam, and to auto-generate at least the starting point, if not the complete content, of a note that they would need to enter into a medical record. to allow them to spend more time during that interaction actually making eye contact with the patient, and to not have to spend after hours time doing mind-numbing data entry. So this is work that we have in a research stage and are working with several healthcare partners to develop.
Okay, so if there's one thing that's clear, the applications are many and they're quite diverse. And so the challenge is to have a conversation about some themes in an environment where the applications are so variable. So I'm going to try a few and we'll see how they go. The first one gets at the question of how transformative this is. If we keep a focus on sort of the diagnostic and treatment part of healthcare, the historical model is you have a very highly trained clinician who learns a lot and is tasked with keeping up with the literature, and they apply their knowledge to the individual patient, and we expect them to adhere to a certain standard. As we move to these more automated methods, they can augment the information that the clinician has, and that's just a better library, a better set of resources. But at some point, it sounds like we start to flip to where the automated information generation may surpass the skill and the capacity of the clinician, which fundamentally alters the dynamics here. So my question to each of you is, where are we in that continuum, and what are the issues that arise as we begin to move in that direction, from everything from professionalism to liability and accountability to resource use? That just seems like a major pivot. So where are we in that continuum, and what are the implications? Who wants to start?
I can start.
Chris.
We build surgical robots, and a surgeon sits at a console and performs a surgery with the robot as an intermediary. And when people hear about surgical robots, the first question they always ask is, well, when's the robot going to do the surgery all by itself? When are you going to automate that? And the short answer is it's going to be a really long time. We have an existence proof that if you take a natural intelligence, if you take a human being and you train them and you sit them at this console, they can do all of the motions of surgery. A complete surgery can be done. So if you could train a natural intelligence to run that robot, you'd be able to automate surgery. But as Lizzie said, we're so far away from that we've got very narrow areas of intelligence that we're thinking about. The other aspects of this come into these fundamental questions that we're going to have to answer as a society, which is, when an algorithm makes a mistake, who do we blame? And whose fault is it? And how much are we going to tolerate there being mistakes made by automation, even if there are fewer mistakes than are being made by the humans? We're going to have to sort this out in cars first, so we're not even going to touch it in healthcare until we've already figured out, who's at fault when there's been a self-driving car accident. But we will learn a lot about both our tolerance for risk and our tolerance for errors coming from algorithms as a society, and who we do choose to blame when something goes wrong in that kind of a situation. And so we will continue, for a very long time, having our clinicians in the loop on this, and but the support structures that they will be getting from their AI are going to be increasing in sophistication, to the point where at some point they are teaching them, not just helping in a decision. But actually performing it, I'm not sure, it's not just a technology problem.
Yeah.
So the complexity of surgery, even for a non-clinician like me, that's pretty easy to imagine. But in some of these diagnostics, it seems like we could get there earlier. Mike, I mean, you mentioned the computer going through all the images, but they then hand that off to a clinician.
Yeah, I think that's going to be the model. little less than 10 years ago, I ran a business that had 50 pathologists. We were doing diagnoses of blood cancers. And they were all depressed because they thought they were going to be replaced by computers very soon. But I don't think that's how it's working out. I'm not saying there's not some point in the future, but I think it's the centaur model that people have talked a lot about, which is half human, half computer. So the computer will pick up more routine tasks. There may be some tasks that it can actually do better than the human, very specialized, where it's doing an imaging thing and it can pick up more information. It certainly can piece together more disparate sources and present that in a way that a human just can't comprehend that much at once. But I still see us many years away from taking the human out of that loop. And that's not even what we're trying to do. We're trying to put tools in people's hands where they can do their job better. And again, I would also come back to this focus of care. There was a study a few years ago. It's not an AI thing, but it's a similar concept where this was, I think, done at Memorial Sloan. They took 700 or so late-stage cancer patients, and all they did was once a week ask them how they were doing on a clunky web browser. And then they used a relatively simple set of algorithms, not even AI, and they fed that back to the care people, and it focused their attention on the sickest patients, and they got a 4-month life extension benefit on that. So I think we can't underestimate that getting humans to do the things humans can do is unbelievably valuable, and I think we have a long way to go before the machines are replacing the humans en masse or end-to-end in any of these processes.
I think one topic that's quite important related to whether, how, and when we'll use AI systems is interpretability and explainability of understanding how an AI algorithm made a particular classification or image. And this is important for a number of reasons. We need to understand and have confidence that these things are consistently behaving the way that we hope that they will. We also need to be able to detect and prevent abuse and fraud. And third, optimally, we would love to be able to actually learn from the situations where we achieve superhuman capability and the computer was actually able to do something that humans were not. You sometimes hear the term black box. What I actually have been very excited about is the fact that there's an increasing number of methods that allow us to understand how and why particular classifications or decisions are being made. One of the ones that we use frequently at Google, it's called attention. What was the model attending to? What specific subset of the input data was most influential for the final decision that was made? In the case of an image, so in the case of an image, let's say we're back to talking about the lung CT example. What pixels in that image did this model believe influenced its prediction of whether this individual has a nodule or has a cancerous nodule? So what it does is this allows us to generate these heat map overlays, specifically lighting up the pixels in the image that led to that classification. This is also how we can sort of auto-generate a summary of what's in a general picture. We could say, oh, you thought that was a cow and that was a fence, or you completely got it wrong by generating these overlays. In the case of text analysis, it's going to be able to surface which were the words and which were the phrases that were used primarily to be generating these predictions. As an example of this, our team has done a lot of work looking at what potential signals are available from a picture of the back of your eye. In particular, are there things that humans can't detect? And the answer is yes. We actually found that with fairly high accuracy, we can assess someone's cardiovascular risk from a picture of the back of their eye. When we applied these attention models to that problem to say, okay, well, what specifically does the model think is informative about this question? The heat map overlay is of the blood vessels in the eye, which when you think about it, makes biological sense. And this is what helps us to build more trust in these models and potentially gives us avenues to pursue to understand why it was that they were able to determine something with accuracy that a human wasn't.
Let me again speak about low-resource communities. To set the context, in a country like India, there are about 800 million people who rely on the public health system. There are about 27,000 what are called primary health centers that have a medically qualified doctor who has a basic medical degree. About 150,000 sub-centers, one for every 4 villages roughly in India, and they are run by nurse midwives. They are not doctors. But that number is still not enough to handle the large number of patients, and many people simply don't go because of the time and effort it takes to get to the nearest sub-center or the primary health center. So they operate on the basis of using frontline health workers. These are in India and sometimes called ASHA workers, and these are community women, typically not high school graduated, who are now trained by these nurse midwives and doctors, and they operate under certain protocol and procedure to visit families, community families regularly. And as you might expect, a lot of their effort really focuses on maternal and neonate child health, because that's the primary place where they can actually make a difference. Now, we're talking about how AI can augment. Now, clearly here is a case that we just don't have enough doctors. We have 30,000 patients per doctors, and the doctor's care is not available to every patient. Nurse midwives are outreach workers, do some amount of triaging. The more we can increase their capacity to better do that triaging, the more they can measure things, the more they can actually have decision-making systems behind that will actually learn from doctors and help the health workers ask the right questions, the better they'll be able to triage. So here's a case where I don't think it's far-fetched to think about the capacity of AI-based technologies immediately increasing the way in which care can be given, even while the system is struggling to find more doctors.
So I want to.
Alan,
Yeah,
actually,
go ahead,
if I could,
Yeah.
just an observation in building on some of the things that you guys were saying. One of the important things to understand is if you want an AI to be able to make good decisions based on a data set that you've given it, you actually need to be sure that you've given it a complete data set. Because if you're saying where is the attention being paid in an image, for radiologists, we don't encounter CT scans or images of the eye in our normal daily life. And so we're not bringing a lot of contextual information. We're not bringing a lot of information outside of the image itself. So you can train image recognition AIs on just the image, and anyone interpreting that image is only using the image. But making decisions on midwifery and what kinds of things you're going to be doing in a village, you don't know all of the information that person is bringing to bear in the decisions that they're making. And so being able to predict what is a complete data set that's necessary to train the AI, you may be missing out the critical component that is actually determining whether they're making a correct decision or not. And so, yeah, these are the differences in how amenable is the problem you're solving to actually having a complete data set.
Yeah, so it's funny, I was about to ask a question and you took a somewhat different angle on it. So we think so much about big data and AI as this innovation, and you can't go to a conference without everyone, if innovation's in the title, then everyone has to be in that session. That's why you all are here. But what I'm hearing is most of these applications are about improving capacity and accuracy, which is phenomenally important, particularly in low resource, but even in high resource environments, we're trying to be more efficient. But it makes me wonder something that I hope you'll convince me that I'm wrong. And what it makes me wonder is AI actually a barrier to innovation? And the reason I come to this question is, Lizzie, as you said at the outset, we don't have general intelligence AI. So what we're doing is we're throwing a technology at problems that we've already identified with approaches and solutions that we've already identified, and we're improving capacity and accuracy. But innovation is about taking a very different approach, seeing a problem and thinking about it differently, or coming up with a solution that no one else ever did. And AI isn't going to do that. Mm-hmm. So I wonder, just again, talk me down, convince me that this is not actually reifying status quo healthcare, maybe making it more efficient, but swinging our attention to something that's less innovative than is possible.
At least
Please,
in our field,
make me feel better.
Which is, so I don't know how to make you feel better about the practice of medicine. I have to think about that. But the first thing we do is try to discover new medicines. And our scientists spend lots of time trolling through literature for ideas. Yeah, it's actually quite helpful. It's surfacing stuff that then they can put together into innovative ideas that no one's ever thought about. So, that's a natural language processing application. But again, the idea is I want the scientists spending time interpreting experimental data. I don't want them fiddling around with getting it. I want them thinking about what are the insights from the literature. And the AI sometimes pulls literature they would never read, right? And that's where you get the innovation, because they can only read so many journals and follow so many journals. And then they do some Google searches or Google-like searches, and that's helpful, but they don't hit the right keywords or the right stuff. And the AI is constantly pulling out surprising, and most of them are not relevant, but a few of them are interesting. And then a researcher says, well, I wonder why those things are related. Or I wonder why in this field it's not related to mine. Someone was talking about X. And then they get a really great idea. So it's still dependent on the human. I'm not saying they're doing it for them, but I do think, when I see my researchers, for a while we had, in fact, there's someone in the audience who fixed this, they would go to one machine and write down the data, and then they'd go to another machine and type it in. That's just a waste of time, right? You want that all to happen, so that's not what they're doing.
So actually, Lizzie made a point about what is good old-fashioned AI and modern AI, which is the machine learning component. See, AI is not a technology that's baked in one place and applied everywhere. It is one kind of method, but the whole point of machine learning is that you give it the data that is relevant for your context and your situation, and you train it over there. I mean, you need to know from examples what the data, how to interpret the data. It's not going to just magically figure it out itself. You need to teach it. But if you can teach it, you can actually train it and customize it to different situations. So in a sense that AI, I think, is open technology that, for example, as Catherine was saying, that even in interpreting the diagnostic methods that may be done, we can apply the context and say, how do I actually read it, given this is the population, this is maybe the lifestyle, this is the dietary habits, this is the prevalence of disease, and bias the outcome according to that learning, right? So in a sense, it allows you to do innovation in place rather than being a barrier. I think it's potentially one that's capable of expanding the scope of innovation overall. I mean, the one device, by the way, I should mention, one technology that we find is universally applicable and has become fundamentally necessary for all this actually is a cell phone. This is one technology that's made in one place, applies everywhere, but that's the delivery mechanism for AI that makes it all possible.
So I would say at a fundamental level, every single one of us up here are trying to solve real human problems, clinical problems. We are trying to solve issues that are out there. AI is a tool. And we're applying AI as one of the possible solutions to the problems that we're going, oh, it's a really cool tool and it can help us do a whole bunch of different things, but it's not going to drive the innovation. What's going to drive the innovation is us looking at the real human problems we're trying to solve and then figuring out what in our set of tools in our toolbox is going to help us solve that the best way we can. So thinking that AI is going to drive the innovation is the tail wagging the dog. It's really the fundamental problems we're trying to solve that are going to drive the innovation. AI is a tool.
And I'll just say, I was never thinking AI would drive it. The question is, does it actually potentially impede it? But I'm a lot better than I was 10 minutes ago. It's good. Lizzie,
we had talked you down a little while ago.
Down.
Okay.
I'll say a couple of things. One is, if you're interested in innovation, there is a panel on innovation in this tent that follows this session. I think a lot about the question of what is the possible version of the future that I would love to see, and how does that inform the incremental steps that we're going to need to take to get there. And I would agree that a lot of how we're using AI in health and healthcare today is incremental. It's taking specific, well-characterized tasks that humans do and seeing if we can help extend capacity or improve accuracy. And I think that serves two very important functions. One is we're not as accurate as we can and want to be, and we don't have capacity to support what we need to do. So it is objectively valuable. But arguably even more important is I think that it's building confidence, that we can use this technology in ways that are rigorous and robust and helpful, that lets us be braver and bolder in terms of how we think bigger. Now, this isn't really directly related to the question of is there an opportunity cost in terms of mind share for other ways to approach problems? I'm not personally worried about that, but that's how I see the specific sort of opportunities to improve, extend, and automate current clinical tasks.
And certainly in the driving analogy that was given earlier, or application that was given earlier, there's lots of supports for active driving that are automated that have given us some confidence as we move towards autonomous. So that path makes sense. No, I think you each gave me some very concrete reasons to see how AI liberates human potential to focus on innovation, and even though it's not the source of the innovation. I thought that was very persuasive. So what I want to do is, we've had a number of references to low resource settings. I do want to turn to Anandan to talk a little bit more deeply, particularly because something you said this morning about just the data sources being a huge barrier. Catherine, you have also done some work in this area. You alluded to it with the supply or the existence of surgical capacity. And then we'll probably, depending on how long these take, with maybe a follow-up question, we'll bring the rest of you all into the conversation. But let's talk about low resource settings.
Yeah, there are basically three parts to developing an AI or any other solution for that matter in a low resource country. One is, of course, finding the right use cases. As I said earlier, that you do in consultation with the people in the domain who know what the priorities are, because the choices are so many and you don't know which is more urgent, so you have to pick. Now, having done that, if you're thinking about, like all of us AI researchers do, I'll go collect a data set, I'll annotate them, the way AI works, by the way, in the machine learning is that you take a lot of input information and then you take a subset of it where you might have known outcomes and use that as a training example. So it's learning the mapping from the input data to the output, and then train it and then apply it to new data. The problem is that there is simply not enough input data. In public health domains, the data is sparse, meaning that some people are covered, some people are not. Very little longitudinal data. The data are incomplete, meaning for the same person you may not have a lot of information. They are often incorrect, noisy, and they are often false. As I said, in the baby weight, for example, it's not uncommon for people to write the weight of 2.5 kilograms as the baby weight, because that's the threshold below which the baby is considered critical. Why? Because they eyeball it and say, okay, 2.5, it looks okay. But you'll see a series of 2.5 kilograms next to each other, something's wrong. And if this is the data on which we are going to actually train, or for that matter, any other thing about diagnosis and so on, we have a big challenge. So finding good data requires a certain amount of investment of effort and creating perhaps an ecosystem. But equally importantly, you have to start instrumenting other caregiving methods to start producing data. It remains a huge challenge. And the last part is that even if you do all of that, if you want to actually do some field trials, there's no way you can actually take the solution to the end user. Now, of course, the end user, being a poor mother in a village, is not going to be able to use your solution. You will go through the frontline health workers, but you cannot get to them. You need to work through the organization and the agency that's working with the particular government, usually a state-level government, which may or may not be ready to take this and then find the right match, and in order to be able to deliver the solution. So fundamentally, every one of these requires special effort. And you kind of have to start with the places where you can make progress, so that hopefully those examples will help others come around.
So everything you hear from me is through the lens of surgery, but it's one of the things that you can tell when watching a surgeon in the US is often you can tell where they trained, whether it was the East Coast or the West Coast. They've got techniques, they've got ways in which they use particular tools. And so if you train just on West Coast surgeons, the East Coast surgeons are going to see the kind of techniques that are being used, and they're going to look foreign to them. You go to another country where the same surgical products, you can't get a stapler or you can't get a particular instrument, and the techniques that evolve there are very different from what you're going to see in the data sets that you get out of the United States. If you go into an under-resourced area, things that you assume you can use like a stapler, they may suture something instead. So you see regional accents, but you see globally dialects in the way that people practice certain procedural medicine. If your data sets don't include all of the people that you're trying to coach or analyze, you've got the tyranny of the data set that you've used. You average the entire data set that you're using, and you say the best procedure is the average procedure of this entire data set. And that's not true. There's going to be sort of regional clusterings of your data around best practices that correlate to that region of the world that those pieces of data are coming from. And so when we look at being able to create tools that are going to be used globally, our data sets have to be global. And we have to really be thinking about the way medicine and surgery is being practiced there. And so what I might think of as best practices in a certain environment is only best practices in the environment that that those were developed. And so I think this is a really important part of the way we're thinking about using these tools globally.
So let me just follow this thread a little bit further. It's relatively easy to contrast an application at Memorial Sloan Kettering and measuring birth weight in rural India, but there's a whole lot in the middle. Mm-hmm. And all of you are operating in environments that span that range. So reflect, if you will, on not just the question of whose data are used, but then who owns the algorithm? Mike, you describe, screening for images. Well, that's presumably an investment that your company made. How that's proprietary, presumably. I'm just asking these questions. How do we think about spreading that knowledge? How do we think about equitable access, the transparency that creates trust? The flip side is if it's a trade secret, if it's to be valuable to your company, there's only so much you can share. So I just wonder if we could sort of use this contrast between high and low resource as a framing question around some issues of ownership and equity. I know, Lizzie, you've thought about this a lot. Maybe I'll turn first to you.
Yeah, a couple of things. This came up briefly this morning, but from my perspective, one of the ways that Google can actually help the most is to be developing capabilities that lower the technical barrier to entry for people to be developing their own models that are customized to their own problems and their own local contexts. And this is tools like we have one called AutoML, where you don't have to write a single line of code. It's facilitating the process of bringing AI technologies to your problem. But it is not fundamentally one where Google takes possession of your data and Google teams build your data, and it introduces these questions of who's owning the problem. It also allows the type of customization that is typically quite critical for problems in low resource settings where you really need to bring that specialized understanding of that problem to bear.
Mike, how do you all think about these issues?
Yeah, so I think this gets to a really fundamental problem with all of these technologies, which are incentives and how systems are designed. Because while there are data gaps and then there's data engineering problems, we can always have better algorithms, I still think the single fundamental problem is this. So if you take my example of the imaging algorithm, why does that work? Well, we have a bone medicine and we are excited about it. And we want more people to be diagnosed, not because they'll directly go to our medicine, but we're trying to expand that funnel. We have a little company, so we didn't fight with them over the IP much because we're happy if everybody uses it, right? There's other situations which are competitive where that would not be so much the case. So I think in every one of these cases, you actually have to work back and ask, can I align the incentives properly? And sometimes it's a public-private partnership. So in the UK, they have the UK Biobank. They've collected 500,000 high-quality samples, right? And they do have private folks come in and work on it, right? There's a company that has done a little bit of work sequencing, I think 50,000 of the 500,000 they have, but they will then make that data public after a relatively short period. I can't remember the exact number. So I think this is the single hardest part of getting these technologies from really cool ideas that work in narrow cases to actually changing dramatically how the healthcare system works.
See, in regular tech world, right, one of the things that has enabled a lot of growth is having open innovation ecosystems. Open source has been a very important driver. In fact, Google is a great champion of this. In low resource situations, one of the big problems is there's not enough capacity to pay. So a lot of the innovation has to happen in an open fashion and in a shared fashion, because no single innovator has the incentive to go deep and invest a lot, leave alone the innovation, but going to market is equally difficult. So we have to create ecosystems where partners can come and play, and also go through the process of creating the ecosystem of delivery. Fortunately or unfortunately, currently the situation is that this has to be done largely through government and philanthropic initiatives without a lot of IP ownership, because there's just not enough players who have the strength to do that.
Catherine, you moved from company to foundation, so it's...
For exactly that reason.
Yeah, so tell us,
so
I mean, this seems
wonderful
really
setup.
important. Yeah.
So I've been with Intuitive Surgical for now, I guess, 12 years, and ran research and global strategy. And the conclusion that I came to was that the data needed to be open and available for everybody to use. So this past year, we put together the Intuitive Foundation, and one of the big projects that we're working on is building a global database of procedural videos with associated metadata that will be open for researchers. So we're still working out, any foundations out there want to come in, I'm coalition building right now, but being able to allow people to build products on top of that, but essentially keeping the data in an open commons, kind of like the Wikimedia sort of structure, so that AI researchers who can't get access to the clinical data and clinicians who don't really have connections to AI and ML researchers, that this is a place that they can come together. And so we've come to that exact same conclusion, that the data need to be a commons, and that all of the other things can get built up on top of that, and that there's a strong role for philanthropy in that, because if you try to extract value out of the data, you get in the way of the data aggregation. And what you really want is to get that there and then allow the value to get built on top of that.
So
Can
I want to
I
put...
give one
Yeah.
one very quick
Please,
story?
yeah, and then I'm going to ask a follow-up, and then I promise I'll
To just
get...
draw a distinction between open for research and valuable for AI.
Yeah.
Before we started working with low-dose CT, we were working with chest x-rays. We were interested in finding nodules. Google does not have a large corpus of this type of data, and we had to rely on partnerships and public data sets. And one of the largest to date public data sets was about to be released. We knew it was coming. We were excited about working with it. We ingested it into our system, and we started training models. And we thought, wow, our models look great. And as we normally would do, we pulled up a couple of examples of cases that we got wrong. Cases where we had predicted that there was a nodule and there wasn't, or that we predicted there wasn't and there was. We were sitting in a conference room. We were simulating a reading room. We pulled down all the shades and the blinds. We had a couple of chest x-rays up on large monitors. And the room went really quiet because we realized, as some of you are probably guessing, that there were pen markings on these chest x-rays that were encircling or pointing arrows at the findings of interest, which, if you're trying to develop automated models to be able to detect these things, is quite problematic. So
Makes it easier.
Does make it easier. You know, lessons learned for QC, but it is critical that we are getting larger sets of data available for use, but there does take some intention to have these data sets be valuable for AI applications.
Okay, so I'm thrilled to hear the discussion of data access, and we had a really interesting paper in the journal about all of the efforts or a variety of efforts around the world around data sharing. But I want to push to the next step because it's relatively easy. I'm not saying it's easy. I know it's not easy, but it's relatively easy to talk about data sharing because each individual actor benefits from the data pool being larger. And in most instances, no individual actor has sufficient numbers to do everything they would want to do. But I want to go further down the chain to algorithms, to applications where, at the end of the day, if we're going to have equitable or some form of dissemination, diffusion beyond an individual private enterprise, we have to be willing and able to share algorithms and workflows and all of the other surgical procedures, not just the data. So imagine a world, I know it takes some imagination, where we've solved the data access, confidentiality, but pooling, sharing problem. How do we solve the next order of problems so that we can all benefit from these developments?
So you mean like an algorithm marketplace?
Yeah, I mean, I don't know. Use that AI creativity to solve this problem.
Well, so we have a few structures that have organically grown up around these kinds of things where Researchers love to publish their algorithms and to share, and you get, Google's a good example of the open source tools. So why people like to contribute into this commons is because they're saying, if I do something and everyone else can see it and can benefit from it and they can build on it, it's an enormous sense of community. And the academic community is driven by this betterment. And so we spontaneously see groups growing up and sharing. And the number of hours that people put into, I use the Wikipedia example, just editing, because they're doing this because they want to improve the world at large. And I see that same kind of human nature playing out. If you can provide these data sets, people will be sharing what they do with it. There will be quite a few people who make their IP and make an entrepreneurial company around it and sell things based on what they're doing. But the people that are open are actually often moving a lot faster than anyone that's branched something off. So
I'm less concerned that this is a problem with data, because without naming names and talking Lizzie's book, there is a large company sitting to my left that has been very open, that has, now they've used their cloud in some ways to help, right? You get into their cloud and you can get access to an unbelievable workbench that they've assembled for you to use. On the other hand, there's another large company, many of you have their products in their pocket, that for a long time was very, very closed. And they have not done as well in this space, because it's very hard to say, we've got all the answers and you can just sit on everything. So I don't want to say it's perfect, but I'm much less exercised about that than the access to the underlying data.
Yeah, the less open you are, the more you're going to fall behind.
Because I think, again, Google shows you don't have to, now, they're not about to publish page rank, I think, for us, but for many algorithms, you guys are incredibly open and generous with what's out there, and we benefit greatly from it.
Yeah, see, for us, there's both a particular or specific or personal angle and a global one. For example, when we were looking at these low birth weight babies, we looked around the computer vision literature and found how people are doing things, but not for babies. They were doing adult body modeling, and that has a lot of very interesting applications, you can imagine, from movies to fashion to all that. But that core approach actually translates over. It has to be redone, adopted, and all that. And the particular people that are working on it were quite willing to collaborate. And we are actively collaborating with the people that have been doing it. One of the things we found is that when you go with the idea that you do something for social good, lots of doors open. People are quite open and willing to collaborate. That said, however, these are just one-offs. I think what has been done in the industry, and again, Google is a leader in this, to create a tech platform, a bunch of APIs, bunch of reference architectures for doing deep learning and such, that other people can pick up and use and build and leave behind. And something similar to that, along with the data ecosystem, has to be created for health and global health. And that, I think that's a journey, but clearly I think there's a lot of interest to do that.
That's great. Good. Well, we have left some time for you all to ask your questions, so thought there might be a few. I see a little cluster right up here, so the microphone carriers, these two in the front row. Is that Patty? We'll get a microphone back to Patty.
Hello, my name is Jason Helgerson, Helgerson Solutions Group, but for a long time I was New York State Medicaid Director. So a lot of my question comes from the context of vulnerable populations and the people that the healthcare system often leaves behind. And I kind of want to echo Alan's earlier point, and I feel a little bit more concerned, even you, Alan, in the sense that it feels like AI in the use cases that were given are more sort of like incremental improvements on a platform that, in my view, is burning. You mentioned some stats. Billions of people don't have access to basic services. That's just the reality of the system on our planet. And so my concern is that we can't train our way out of that. We can't hire our way out of that. And so my fear is that technology has to be the solution. And especially for you in the center here at Google, the company, one of the most powerful companies in the history of the globe, has a unique role, responsibility, in my view, to actually create a vision for how we can fill that gap. And my fear a little bit with AI, and maybe you guys can dissuade me of this fear, is that we're a little too deferential to the healthcare system itself. We're a little too deferential to the role of physicians, at least historically they've played. And my hope, especially for companies like Google, is not to acquiesce to that fear and be willing to say, maybe in the future, machines will in fact replace human beings. Because I feel that the only way we're going to solve these huge access problems and really achieve equity is if we can find a way to automate. So interested in your thoughts.
Yes, fantastic remarks, and I agree with, I think, everything that I heard you say. Vulnerable populations in healthcare was my self-defined focus when I was in school, undergrad. When I was in graduate school, I studied obstetric pharmacology because it angered me that we were basically doing research on pregnant women by giving them medications that we had never studied to understand if they were safe or they were effective. And the equitable distribution of risks and benefits from AI technologies, I think, is one of the most important topics. And the reason that I am at Google is because I think it is uniquely positioned to have impact on order of billions of people on this planet. But it has to be done being mindful of those who are already winning and those who are already losing. I think I don't have answers to your questions, and I don't think that there is a single answer to your question. But part of the reason that I took the job that I did is because we need to have people who are thinking about these problems and are engaging with people like you to better understand where are we doing okay and where are we not? And what are the ways that we can make sure we have, one, direct representation. I was funded on a grant that studied tribal communities of the Pacific Northwest, and understanding the extent to which there can be harms that are unintentional that result from people trying to do good things is arguably without limit. Understanding the extent to which we harm people by trying to protect them from risks and then exclude them from the benefits of our work. So part of the reason that I love conferences of this nature is the chance to hear in a very concentrated manner from people who are very, very focused on underserved communities, vulnerable populations, and regional and localized needs. But that's why I'm here. And I intend to be working very hard at Google to make sure that these issues that you raise are prioritized and are heard. And insofar as I'm able to speak on their behalf, I believe that most, if not all, of my colleagues feel similarly.
I think to me, your message was health system requires disruption. Technology/AI might be the way to do it. And technology companies like Google should not be afraid to go take it all the way. I totally agree. One thing that to look at is that though disruption can sometimes more easily begin from the bottom, where the health system is actually not functioning. And in some ways, that's where we see the opportunity to get in. So.
Yeah, I actually disagree with a couple of the premises that you have, because you're saying the population that needs services is the problem. And I actually think the population that needs services is the solution, which is why I am much more about education. There are brilliant people everywhere in the world, and a lot of them are growing up without the benefits of an education. But you can get a population to be able to care for itself and care for one another if you can figure out a way to get people the training that they need to be able to be those carers. And you don't think of them as passive recipients of a healthcare system that we're structuring in order to serve them, but active participants in being able to learn to care for themselves and learn to care for one another. And so why my focus is on the educational side of it is I believe that the doctors and the nurses necessary to take care of one another are in those populations that they need to serve. And we need to fix how we're teaching them.
Can I take a slightly different angle on it, which is I disagree with another premise, which is that I'm a little skeptical. Again, very impressed with Lizzie and the work that Google does, but I'm a little skeptical that its tech companies are the most obvious solution to the problems you outline. And the reason is we've had to move fast and break it ethos.
That's Facebook.
I recognize that. I'm not saying that's Google, but I'm a little concerned about that ethos being the ethos that we got for the healthcare system. I think it's got to be policy, right? Maybe it's boring, maybe it's not popular, whatever, but I think it starts with thoughtful policy to address these issues. I'm not saying that AI and things can't help. I think it can be tremendously helpful. I'm a little worried that we blow up the system and assume that what comes out of it is better than what we have. It's exactly what you were talking about. We may be trying to help, but you may get, some people doing, Facebook moderation in ways that you don't like, and you didn't think about that ahead of time because it's a complicated system. So it's not that I don't think the idea is right or the push is right. I just don't leave out the policy element, because a lot of the problems we have, not in the underdeveloped systems, but in the developed systems, are policy interlocks that make it very hard to make logical changes.
We had another question here, right here in the front row, and then we're going to go to Patty. We'll take you, and that's probably going to be about the end. I'll try to
we
keep
give long
questions and answers.
We do.
Yep.
All right, so I'll try to make this quick. Dave Prakash with Anthem's AI division, and the question is somewhat twofold. So the first one is,
How about let's make it onefold.
so we're trying to automate the human process with AI. How do we get past that and look at issues that go beyond human discernment? Because I think there's a lot of potential there, and that affects medical education and so on as well. What makes for a good medical student in the future in this world?
So I'll go back, I'll leap in on this one. If you say, I'm going to start with AI and I'm going to look at all the places that I can apply it, you're going to stunt the kinds of problems that you're solving. If you say, I am looking for a better way to detect cancer and I can light it up with a fluorescent molecule and I can see it with a camera and that goes beyond a human's, that's got nothing to do with AI, but it's a really good solution to being able to solve that original problem. I would just keep coming back to, AI is the tool. We have to not lose track of what are the actual problems we're trying to solve and whether AI is a good solution to that or there are better solutions to the problem. So that's...
Good. All right, we can get a few more in at this pace. So we're going to take these two over here. Patty.
Thank you. That was a great panel, Patty Cabot. I think we all know that we have to lower healthcare costs in this country, but we also know that our history is every time we introduce new technology in healthcare, it raises costs. And robotic surgery is a great example of that. So how do you see this growth of new technology actually helping us lower healthcare costs, not more screening, not more drug therapy, not more tools that add costs? And I'm not sure I see how what you've said so far lowers costs.
So I'll take a shot at that, which is what we're also seeing that is more revolutionary is you can use data techniques to actually understand what's happening in the system and run counterfactual experiments and try to really understand what would have been better. So for a long time in Medicare system, they couldn't even understand what they were paying for, right? I was in the diagnostic field for a while, and you coded things in called CPT codes. And it said you ran a particular oligonucleotide assay. Don't know for what, and we're gonna pay you for that. Right? And so it's very hard to figure out what you should actually do if you don't even know what you're actually doing. So I do think these technologies can hopefully give us an actual picture, both of what's happening and maybe even a good picture of what would be better. I still come back to policy, though. That's not going to be sufficient. I think it can inform it, but I think you're going to need policy changes to move to a system that rewards innovation, but then can clear out some of the older stuff and the older ways of paying for things and get that off the books to pay for the new innovation. And for me, that's a political decision, not just a data issue, although I think data will be critical to helping make the right decisions.
Ultimately, it's a question of amortizing the cost of innovation, right? In other words, the reason why they go up is because the innovation required a huge amount of capital investment, and somebody is going to try to make money out of it. I don't know if there's a panacea, but really democratizing the process of innovation and making it open and available to a large number of people by sharing the key elements, which is in this case will turn out to be data, is probably the only way to do that. The more people are there, the less the cost will be.
Well, and I also would say we need to be careful about what we think are costs versus value. Big pieces of surgical equipment like surgical robots are often pointed to and said, oh, they raise the cost of healthcare because the math is really easy. You spent $1 million on a piece of equipment. But what's harder on that calculation is figuring out what were all the costs downstream that it avoided. And if you do a net value on a hospital system that has this equipment, is it serving more people for less cost, or is it, or getting better outcomes for less cost, or is it for more cost? And what we've seen in US hospitals, so I'm going to defend my robot for just a moment, is that hospitals will get one, and they start looking at the bottom line in terms of costs of complications and costs of readmissions and things like that, and pretty soon they find they have 7. Because for every single one that they're bringing in, they're actually reducing the overall cost of care to treat. And so one of the nice things that's happening in the US is we're moving towards bundled payments and being able to look at an episode of care. And that will actually make a more focus on really looking at what it costs to do care. But these technologies are being used in systems all around the world, not just the US system, where everybody's already looking at the holistic cost associated with that. And every new technology is going to need to earn its way into our healthcare systems.
So I'm sorry I'm not going to be able to bring you in. I'm very sorry, but we got 80 minutes. I can't turn it into 90. Let me just close by saying I hope from this deeper dive you got a sense of the heterogeneity of the potential applications in AI, that its immediate potential is largely focused on improving capacity and accuracy, but there's a lot of unknowns about how disruptive it will be, whether it will lead to the cost savings. I'm going to challenge you on those robots, by the way.
Absolutely.
But fundamentally, I think the remaining issues, in addition to the technological ones, which we've learned a lot about today, there are issues of policy, there are issues of infrastructure, and that if we think about those, that will help us use these applications to be disruptive, to be cost-saving, and not just accretive and additive to a system that has a lot of challenges. So please join me in thanking our terrific panelists.